The magnetic compass, the Earth's magnetic field. Imagine that inside the Earth is a powerful bar magnet. This lies with its blue end toward north and its red end toward south. Its axis is not exactly aligned with the Earth's spin axis. The lines of magnetic force emerge from the red end and re-enter the blue end. These form a field of magnetic lines of force around the Earth. The two places on the Earth directly over the axis of this magnet are the poles. The magnetic poles do not line up with the Earth's true pole. Magnetic dip occurs where the lines of force leave the surface of the Earth. So the closer you get to the poles, the weaker a magnetic compass becomes. Magnetic meridians do not align with true meridians. The horizontal angle difference between the true meridian and the magnetic meridian is called variation. Variation changes with locality on the planet and time. The compass rose on a chart states the variation in that locality. So you must always use this variation to convert your magnetic course to a true course on the chart. You can also find the information in an almanac or cruising guides. So, you can see in the compass rose here that in 1979, the variation was 18 degrees 48 foot east. You can also see that it increases by 4 foot each year. So this is quite an old chart, so it's possible that the variation amounts have changed. But anyway, to work it out, you figure out how many years between 1979 and 2014, which is 46 years. 46 years x 4 feet per year. 184 feet. Remember that there are 60 feet in a degree. So, to work out how many degrees you divide 184 minutes by 60, so 184, 60, read 306 degrees. You can convert 206 of a degree into minutes, taking the decimal portion of the number, i.e. just the digits to the right of the decimal point, and multiply it by 60 minutes in an hour. So, 60 guess on 60 what? 3.6 feet. So there is 23 degrees 3.6 feet of extra variation to add to the variation figure of 1979, which was 18 degrees 48 feet E, or 18 degrees 48 feet, 3 degrees 3.6 feet, 21 degrees 51.6 feet A. Of course, it's going to be pretty damn hard to steer a course that accurate, but it's worth knowing how to work it out properly, as your navigation teacher is going to want to see an accurate number, not just a hazardous guess. If the variation is west, the North Magnetic Pole lies to the left of the true North Pole. If it is east, it lies to the right of the true North Pole. Variation East Magnetic Least. Variation West Magnetic Best. Here are some examples to try. 1. Your true course is 040 degrees T. The variation is 23 degrees E. What is the magnetic course? 2. Your true course is 090 degrees T. The variation is 10 degrees W. What is the magnetic course? 3. Your true bearing is 273 degrees T. The variation is 5 degrees W. What is the magnetic bearing? 4. Your true bearing is 008 degrees T. The variation is 13 degrees E. What is the magnetic bearing? 5. Your magnetic bearing is 273 degrees M. The variation is 7 degrees W. What is the true bearing? Answers. 1. 017 degrees M. 2. 100 degrees M. 3. 278 degrees M. 4. 355 degrees M. 5. 266 degrees T. The boat's magnetic field. A boat has many magnetic objects on there which can interfere with the magnetic compass. This is caused by any iron or steel in the structure, any fixtures or fittings made from ferrous materials, and also other electrical instruments near the compass. For example, the keel, radio fittings, engine, etc. A vessel made of steel, ferro, cement, or iron can have magnetism induced into them from being hammered or sitting in a position for a long period of time. Timber and fiberglass boats are not affected, however. The motor and other fittings can still be affected. These components on a boat can change magnetic properties over time. The compass should be mounted as close to eye level as possible, where it is clearly visible from the helm and away from any magnetic, ferrous material. The lubber line should be correctly aligned when mounted. The errors that this causes to the compass is called deviation. Deviation is the horizontal angle at the compass between the magnetic meridian and the direction of north indicated on the compass. Deviation also changes depending on the heading of the vessel, any structural changes to the boat, the passing of time, mooring the boat near a strongly magnetized boat or structure, lightning, collision or grounding, welding, etc. Hard iron means that the components remain magnetized for the rest of the vessel's life, or permanent magnetism. Report this ad. Soft iron components do not retain magnetism. They adopt the Earth's magnetic field induced into them while on a particular heading. It is called induced magnetism and can gradually change each time the boat changes course. Each boat has its own magnetic field. However, this can be measured and noted on a deviation card. This needs to be checked on a regular basis as the magnetism can change as noted above. To convert a compass reading to a true reading on a chart, apply the following. Compass. Symbols. Deviation equals magnetic. Magnetic X, variation once true. Or to remember, CDMVT, Cadbury Dairy Milk very tasty. Or TVMDC, true virgins make dull company. Deviation west, compass best. Deviation east, compass least. Here are some examples to try. 1. Your true course is 114 degrees T. Variation is 4 degrees W. Deviation is 5 degrees E. What is your compass course? 2. Your true course is 302 degrees. Variation is 7 degrees W. Deviation is 5 degrees W. What is your compass course? 3. Your compass course is 250 degrees C. Deviation is 2 degrees W. Variation is 3 degrees E. What is the true course? Answers. 1. 113 degrees. C. 114. 4. 118. 5. 113. 2. 314 degrees. C. 302. 7. 309. 5. 314. 3. 251 degrees. T. 250. 2. And 248. 3. 251. How to make a deviation card. 1. Ensure the vessel is in normal seagoing condition, upright, and with no magnetic objects near the compass. 2. Check that the lubber line is in line with the boat's fore and aft line. 3. Select a distant landmark clearly visible but far enough away to prevent parallax errors. 4. Slowly song the boat in the smallest circle possible. 5. Take a bearing on the landmark on at least 8 equidistant spaced headings, keeping the boat steady on each heading. 6. Calculate the magnetic bearing and compare this to the compass bearing. The difference is deviation east or west. 7. Plot the deviation onto a table to obtain a deviation curve. 8. From this table you can then calculate the deviations for the headings in between the 8 bearings you took. 9. East should match west deviations. You can also use the sun and celestial navigation techniques to check the deviation of your compass. Here's how to do it at sunrise. 1. Work out your latitude. 2. Make sure you've got a clear sky so you can see the sun. 3. Work out the sun's declination in your almanac. 4. Apply your latitude and the declination to the table to give you the true bearing of the sun at sunrise and sunset. 5. Once you have your true bearing of the sun, apply variation to give you the magnetic bearing of the sun. 6. Sight over the compass when the sun is just lifting above the horizon. Note the bearing. 7. Any difference is deviation. 8. Name it using the east is least, west is best rule. Local anomalies. In certain areas are unusual magnetic disturbances. They can be caused by iron on the seabed, wrecks, or power cables. Other disturbances can be caused by overhead power lines, bridges, steel ships, etc. Charts with permanent disturbances can have a note explaining the disturbance and give a figure by which the variation may differ. You must be very cautious in these areas, especially if you are navigating by compass at night, or if your autohelm is using a compass course. In these areas, do not rely on your compass for a position fix. Healing error. Healing error is caused by objects above or below the compass and can change depending on the angle of the boat's heel. It is like an imaginary vertical magnet within the vessel. If the vessel is heeled over, then the center of this magnetism effectively moves to one side of the compass card and can cause its own deviation. If the vessel is on a northerly or southerly course, then the movement of the vertical magnetic field will be at right angles to the compass card and can cause maximum deflection of the compass from north. However, if you are on an easterly or westerly course, then the movement will be parallel with the magnets on the compass card, therefore causing no deflection, but the card may dip in the vertical plane. Healing error may be identified and corrected by a compass adjuster using a healing error instrument. It is corrected by the appropriate placement of vertical corrector magnets below the compass. The fluxgate compass. This is a simple electromagnetic device that has 2 or more small coils of wire around a highly permeable magnetic material to directly sense the direction of the horizontal component of the Earth's magnetic field. The advantages are that the reading is in electronic form and can be digitized and transmitted easily and displayed remotely and used by an autopilot. It can be sighted in an ideal position, low down in the boat and away from any magnetic influences. The flux gate must be kept as flat as possible by mounting it on gimbals or using a fluid suspension system. All the same errors are inevitable when the vessel is being tossed around by rough seas. Flux gate compasses are also subject to deviation and variation and healing error. However, it may be possible to apply variation electronically, and there may also be a facility to swing the vessel and apply deviation automatically. Taking compass bearings. Whatever type of compass you use for taking a compass bearing, be it the steering compass, compass binoculars, or a hand-bearing compass, you must convert the compass bearing to a true bearing before plotting it on a chart, i.e. apply variation for the location you are in. It is pretty difficult to take a bearing with a steering compass, so a hand-bearing compass or compass binoculars are better, however, because these two compasses are mobile. It is difficult to know their accuracy in regards to deviation. It is best to use these compasses in an area of the boat that is least likely to be affected by any deviation, and for practical purposes, it is best to assume that there is no deviation, but just be aware that there probably is some deviation present, so these bearings should be used with caution.